The vacuum of space, a silent and hostile vastness, presents the greatest challenge to human survival beyond Earth. Without oxygen, without gravity, and with extreme temperatures, space is a place where life as we know it cannot be sustained without the aid of highly advanced technologies. But what does it take to survive in this inhospitable environment? Let's find out what it takes to face the vacuum of space and understand the greatest challenges a human would face outside Earth. The first and greatest obstacle in space is the lack of oxygen. Without an atmosphere, there is no air to breathe. In the vacuum, our body could not survive without a special suit. The spacesuit must be pressurized, ensuring that you have enough oxygen to breathe and allowing the carbon dioxide you exhale to be safely removed. This suit is vital because without it, the lack of pressure would cause irreparable damage to the human body, making bodily fluids boil and vital functions cease rapidly. In addition to supplying oxygen and controlling pressure, the suit also protects the human body from another major problem: extreme temperatures. When exposed to the sun, temperatures can reach up to 120 °C. To survive, a suit equipped with thermal regulation systems is required, capable of handling these extreme variations. Without this control, the human body would be unable to endure, suffering burns or freezing rapidly. Another significant challenge in space is cosmic radiation. In the vacuum, you are exposed to high levels of radiation which can seriously damage the human body. Cosmic rays, solar particles, and radiation from distant sources travel through space at extremely high speeds, and without protection, this radiation can damage DNA and even cause cancer. Therefore, the spacesuit requires an efficient shielding layer to block or deflect this radiation. Without it, prolonged exposure could be fatal. Furthermore, space is a microgravity environment where Earth's gravity is absent. This may seem like a benefit, but it is actually another challenge. The lack of gravity causes muscle atrophy and bone density loss, as the body no longer needs to support its own weight. On long missions, this can have severe effects, making it essential for astronauts to perform daily exercises to counteract muscle and bone loss. These exercises are crucial to ensure the body does not suffer irreversible damage during the mission. Finally, there is the issue of mental health. The loneliness and isolation of space, far from friends, family, and even the familiar gravity of Earth, can be mentally exhausting. Psychological stress during long space missions can affect astronauts' performance. Therefore, it is essential that space missions include psychological support, strategies to manage stress and anxiety, and effective communication systems with Earth. In addition to all the vital systems that ensure survival in the vacuum, such as oxygen, thermal control, radiation shielding, and psychological support, another important factor on a space mission is food and water. In space, resources like food and water are limited, and any failure in supplying these items can be fatal. To ensure survival on long-term missions, a water recycling system would be necessary, where consumed water is purified and reused without waste. This system is fundamental because water reserves are finite, and on a prolonged mission, potable water would become a valuable resource. Moreover, food in space presents unique challenges. Food must be stored and prepared in a way that keeps it safe for consumption over long periods. On long-duration space missions, food must be easy to transport and maintain without spoiling. The food must be compacted and efficiently packaged, preserving its nutritional value, taste, and freshness. Another important issue is the human body's adaptation to this diet. In space, the sense of taste may be altered, making eating less enjoyable. Therefore, astronauts may experience loss of appetite or even nausea due to this sensory change. On very long missions, an agricultural system inside the spacecraft or space station would also be necessary, allowing astronauts to grow their own food. Plant cultivation in space is a growing area of research, with experiments to see how plants behave in microgravity. This would not only provide a source of fresh food but also help improve air quality, as plants release oxygen as a byproduct of photosynthesis. Another important challenge in space is communication. Navigation in the vacuum of space far from Earth would require highly advanced and reliable communication systems. The distance between spacecraft and our planet can be millions of kilometers, making direct communication a challenge. To ensure mission survival, communication systems must function perfectly, even under extreme conditions. Additionally, on long missions, communication with Earth would be essential for monitoring astronauts' health and providing emotional support. Finally, but not least, highly efficient space propulsion systems would be required. Spacecraft traveling to deep space need fuel and energy efficiently, as traditional energy sources like solar power become less effective the farther they are from Earth. The development of new propulsion systems such as ion propulsion or even nuclear propulsion is essential for humanity to undertake longer and safer journeys in space. These systems would need to be lightweight, efficient, and powerful, allowing astronauts to travel great distances without constantly needing to refuel. In addition to all the technologies mentioned so far, another fundamental aspect for survival in the vacuum of space would be protection against micrometeorites and space debris. Space is not an empty place. Rather, it is an environment full of tiny particles traveling at extremely high speeds. Even small particles can cause significant damage to spacecraft and astronaut suits. To deal with this danger, spacecraft need to be equipped with protective shields capable of absorbing the impact of space debris, preventing them from penetrating the ship's structures and causing serious damage. Furthermore, the efficiency of navigation and spatial orientation systems must be considered. Space travel involves covering vast distances, often in regions of space beyond our current understanding. To ensure that astronauts stay on the correct course and reach their destination safely, spacecraft must be equipped with high-precision navigation systems. These systems would rely on advanced sensors and artificial intelligence, capable of analyzing and automatically adjusting the ship's trajectory during the journey. Another aspect that may seem simple but is crucial on long-duration space missions is the maintenance of spacecraft and suits. During a mission in space, astronauts do not have access to Earth-based infrastructure to repair failures or replace damaged equipment. Everything must be prepared to operate for long periods without failure. This means that the systems in spacecraft and suits must be extremely reliable and easy to maintain. In addition, astronauts need to be trained to handle emergency situations and perform repairs on critical equipment such as life support systems quickly and efficiently. Regarding mental health, the issue of isolation in space can be one of the greatest challenges. The lack of contact with Earth, confinement in a restricted environment, and absence of natural stimuli can generate stress, anxiety, and even depression in astronauts. Loneliness and the lack of interaction with friends and family, combined with the constant pressure of performing such a complex mission, can affect concentration and crew morale. To mitigate these effects, missions need continuous psychological support, regular communication with Earth, and recreational activities that help maintain astronauts' well-being. Another crucial point for survival in space is astronauts' ability to adapt to long periods in microgravity. The absence of weight can affect the human body in various ways, such as muscle mass loss, bone weakening, and cardiovascular system changes. To minimize these effects, astronauts require a strict daily exercise regimen. This exercise, performed on equipment specially adapted for microgravity, would help preserve muscle strength and bone density, as well as aid blood circulation. Finally, the ability to think long-term and plan is fundamental. On long-duration space missions, crews need a clear and structured vision of everything that could happen during the journey. This includes not only technical aspects of the mission, but also resource management, such as food, water, energy, and even work and rest schedules. Coordinating all these variables is essential to ensure mission success and crew safety. It is important to emphasize that, in the vacuum of space, humans are not built to survive without supporting technology. Humanity requires robust and well-designed systems to face the extreme conditions of space. And as scientists and engineers continue to improve these technologies, the path toward deeper exploration of the universe becomes clearer. But what can we expect for the future of space exploration? With the evolution of propulsion technologies, the dream of faster and more efficient space travel may become a reality. We are already developing ways to propel spacecraft more quickly than current technologies allow. Propulsion systems such as ion engines and even nuclear fusion propulsion are under study, and these advances could enable faster journeys with lower energy consumption and greater safety for the crew. Moreover, as space exploration expands, the possibilities of establishing colonies beyond Earth gain momentum. In the distant future, the idea of living on space stations or even on planets outside our solar system could become a reality. For this to happen, however, it will be necessary to ensure suitable living conditions, with self-sustaining systems that allow humans to live and thrive in space for long periods. This involves creating enclosed environments that can generate oxygen, purify water, recycle food, and manage the physical and mental health of colonists. However, all of this will only be possible if we continue investing in research and technological innovation. Survival in the vacuum of space is no longer a matter of if, but of when. With the advances already made in space missions, such as the International Space Station and Mars exploration, humanity is more prepared than ever to face the challenges of deep space. Now, if you are as fascinated as we are with the idea of surviving in the vacuum of space, and have explored with us what it takes to face this hostile environment, leave your comment below. What do you think will be necessary for humans to actually live in space in the near future? Which of the technologies we discussed do you find most fascinating? And if you are still curious about the future of space exploration, don't forget to subscribe to our channel to follow more amazing videos about the universe, new discoveries, and the progress of space missions. Be sure to click the notification bell so you don't miss any updates. Keep watching our videos. Click on the video above to continue exploring curiosities about the universe. Until next time.